One more important concept when we're talking about linear graphs is a specific way of writing the graph's equation, and that is the so-called gradient intercept form. And the general equation for the gradient intercept form is the y equals mx plus c, where m is the gradient and c is the y-intercept. Now, if we have this equation, if we have got the equation of the line and we rearranged it into this format, we can say a lot about that graph. For example, just by looking at the number in front of x, we can say how fast and in which direction the graph changes. Is it an upwards or is it a downwards growing graph? Is it a very fast, rapid changing graph, or is it a slow changing graph? But also, if you remember, the y-intercept was when the x-coordinate was 0. But if the x-coordinate is 0, is the m times x will disappear. So y will be equal to c. And that's why we can say that the number c, or the constant in the equation, represents the y-intercept. Now, why should we use it? It's because it's very simple to give extra information about the graph. Those information I just given you, the gradient and the intercept, without having to actually draw the graph or do calculations using the 2 points, the definition of the gradient I gave you a couple of slides ago. So, look at a few examples and read off the gradient and the intercept of these graphs. Well, it's as simple as it looks. So if you look at this format of the equation, the number in front of the x, that is the gradient, so m is equal to 3, and the y-intercept will be the 0, negative 4, because the number here, the constant, is negative 4. Example 2. The gradient now will be the number in front of the x, which in this case negative half, and the y-intercept will be 0, positive 3, because that is the constant, that is the number that stands alone. If I look at the third equation, that's not so straightforward, because the gradient and the intercept can only be read off if it's in this particular form. So the equation first needs to be rearranged. So how can we rearrange it? Well, y has to be on its own on one side, so I'm not going to touch y here, but the 4x have to be removed to the other side, which means I need to take away 4x from both sides. So y will be equal to minus 4x plus a quarter. Remember, if there is no sign in front of a number, that's always positive. Now I can read off the gradient. The gradient will be minus 4, and the y-intercept will be 0 plus 1 quarter. Now, if we look at these three graphs, which one can we say is the fastest changing? Well, if I just look at the magnitude of the numbers, ignoring the signs for a change, the biggest number of the three is 4. So this graph is the fastest changing graph. But this has got a negative sign. So this would be a downward sloping graph. This would also be a downward sloping graph, but it's a very, very lazy graph. It hardly changes, because with the fractional gradient, remember the gradient was the change in y divided by the change in x. And now if that's equal to -1/2, that means if I go 2 points or 2 units in the x direction, I need to go 1 unit in the y direction, but in the opposite direction, because there is a negative in here. So if I go 2 steps in the x direction, I need to go down 1 in the y direction. Remember, one is positive, the other is negative. So 2 right, 1 down. 2 right, 1 down. That's a very, very slow changing graph. Compared to this one, if I look at m being the same, change in y divided by the change in x, which is -4 in this case, well, any whole number can be written as -4/1. So any whole number can be put as a fraction over 1. So this would tell me I'm going 1 in the x and I need to go down 1, 2, 3, 4 in the y. 1 in x, 4 down in y. A lot faster changing. And this one is somewhere in between, closer to 4, because 3 and 4 are much closer to each other than 3.5, but it's a positive number. So that tells me that x and y are changing in the same direction. So if I'm going 1 in the x direction, I'm going to go up 3 in the y. 1, 3, 1, 3. That's again a relatively fast changing graph. Now, it's all nice and lovely with the x's and the y's, but in many practical situations, what's going to happen is you will be given a demand function or an inverse demand function, and you will need to be able to draw some conclusion about how fast this particular demand function changes. So how does it work in the case of the demand function? So what we need to remember is that in the case of the demand function, what is the x coordinate and what is the y coordinate? Well, the general practice is that the y coordinate is always the price and the x coordinate is always the quantity. So if I look at the example, P equals 4Q minus 4, well, P is on the y, Q is on the x, so this is exactly in the y equals mx plus c format. So from this one, just by looking at it, I can straight away read off the gradient and the y-intercept. So the gradient would be 4 and the y-intercept would be 0, minus 4. Example 2, P equals minus 1 over 5Q plus 3. Again, same format, so I can just read off the gradient by looking at it and saying the gradient is minus 1 over 5 and the y-intercept will be 0, positive 3. Now, when you look at the third example, both of the variables, the q and the p, are on the same side. So we need to rearrange this into the p equal format because p is my y coordinate. So all I need to do is just take the 4q away. So p equals minus 4q plus a quarter. And from here now I can say that the gradient is minus 4 and the y-intercept is 0, 1/4. The last example, q equals 2p minus 10. Now, you could be tempted to say, okay, the gradient is 2 and the y-intercept is minus 10, but unfortunately, this is not in the right format because although this is the direct demand function, for us to be able to read of the slope and the intercept, we need the demand function to be in the inverse form when p equals, because again, p is the y-coordinate. So this needs quite a bit of a manipulation, so I need to rearrange. I want p on its own, so the minus 10 has to be removed. And negative 10 to be removed, I need to add 10 to it because that makes it to 0. But if I add 10 to one side, I need to add 10 to the other side as well. So what I end up with is q plus 10 being equals to 2p. Now I'm just going to swap the two sides, so I end up with this nice format. But remember, it doesn't really matter which side you write on the left and which side you write on the right, because the two are equal. Last thing I need to do, I've got 2p, I just want 1p, so I'm going to divide both of the sides by 2. 2p cancels down, so that gives me the p. Q over 2 is the same as half a q, plus 10 over 2 is just 5. And now I can read off the gradient and the intercept. But the gradient is the number in front of the q, so m is equal a half, and the y-intercept is the number on its own, remembering that the first coordinate on the y-axis is always 0.